Okay, let's jump right into this. For decades, the story of how our universe ends had a very clear, very cold final chapter written into all the textbooks. We're talking about an endless expansion into a completely dark, frozen nothingness. But science is an active, living process, right? And today, we are looking at a mind-blowing paradigm shift. Because brand new data suggests our universe might actually have a completely unexpected and honestly incredibly violent new expiration date.
So, for the longest time, the scientific consensus pointed toward this very quiet, lonely finale called the heat death, or the big freeze. The idea was that space just keeps expanding forever, the stars eventually burn out, galaxies drift apart, and the whole cosmos settles into this dark void where, well, nothing ever happens again. But a stunning new cosmic timeline has just emerged. Instead of slowly fading away into that freeze, researchers are seeing hard evidence that space-time itself might eventually slam into reverse, actively shrinking and collapsing inward.
To actually answer this massive, mind-bending question, what is the ultimate fate of our universe, we have to look at the invisible mechanics of reality itself. We essentially have to measure the true underlying shape of the cosmos and track the unseen forces that are currently tearing it apart. I know, it sounds straight out of a science fiction movie, but this is pure observable physics.
First things first, to understand our fate, we have to understand our shape. And satellite data tells us that our universe is astonishingly flat. Now, in physics, that doesn't mean it looks like a giant two-dimensional sheet of paper. It means space is perfectly balanced. If you were to fire two lasers side by side out into the void, they would travel parallel to each other forever, never crossing and never drifting apart. And because of this perfect razor-edge balance, physicists figured the universe would just keep expanding smoothly into infinity.
But there's a catch, and it's the invisible culprit driving that smooth expansion. We call it dark energy. When you look at the total composition of the universe, everything we can actually see, touch, and interact with, the stars, the planets, you, me, all of it makes up a tiny, almost insignificant fraction of existence. About 74% of the universe is actually made of this mysterious repulsive force. We can't put it in a jar in a lab, but we can absolutely see its effects in the way galaxies are accelerating away from each other.
You can kind of think of the universe as being locked in this giant cosmic tug-of-war. On one side, you've got gravity. Gravity is the ultimate cosmic glue, right? It wants to pull matter together, contract space, and crush everything inward. But on the other side, you've got dark energy, violently pushing outward, stretching the very fabric of space-time and driving all those galaxies apart. And for the last few decades, it really looked like dark energy was the undisputed champion, destined to stretch the universe until it completely froze.
So to figure out who actually wins this epic tug-of-war, scientists needed to track exactly how these forces behaved over the vast history of time. And to do that, they kicked off a wildly ambitious experiment. Using something called the Dark Energy Spectroscopic Instrument, or DSI for short, an international team of researchers created the largest, most precise 3D map of the cosmos ever made. They meticulously charted the positions of nearly 15 million galaxies and quasars. And this allowed them to look back in time across a staggering 11 billion years of cosmic history. 11 billion years.
But how do you actually measure expansion across that kind of time? Well, they didn't just guess. They looked for something incredibly specific called baryon acoustic oscillations, or BAOs. Basically, right after the Big Bang, the universe was this intensely hot soup of plasma, and tiny variations in that soup created actual sound waves that rippled outward. When the universe finally cooled down at about 400,000 years old, those ripples literally froze in place. Fast forward to today, and slightly more galaxies tend to form right along those ancient frozen ripples, creating a distinct, repeating pattern across the entire night sky.
And scientists brilliantly use these frozen ripples as a sort of standard ruler because they know the exact physical distance those sound waves traveled before freezing, which is about 500 million light years, by the way. They can look at how that distance appears to stretch at different eras in the universe's history. By laying this cosmic measuring stick across 11 billion years of galaxies, they can reconstruct the exact expansion history of the universe. Essentially, they're tracking the exact strength of dark energy over time.
And this brings us right to the crucial, mind-blowing discovery. You see, ever since Albert Einstein, dark energy has been treated as a constant force. The assumption was that its push remains exactly the same as space expands. But the DESI data is hinting at something totally revolutionary. It shows that dark energy is not a permanent, unchanging engine. The data actually suggests that over billions of years, its repulsive push is fading. It is actively withering away.
Make no mistake, this isn't just some tiny anomaly in a spreadsheet. Like astrophysicist David Weinberg pointed out, this is the absolute strongest evidence we have so far that dark energy actually evolves.
If this holds true, it represents a foundational crisis that literally has top astrophysicists all over the world rethinking everything. It shakes the very bedrock of modern cosmology. Because if dark energy isn't a strict constant, well, the ultimate future of the universe is suddenly thrown wide open.
Let's compare our fates with this new data in mind. If dark energy continues to weaken like this, that widely accepted heat death, canceled. The outward push of the universe will eventually stall out entirely. And when that happens, gravity, that patient, relentless force on the other side of our cosmic tug of war, takes the wheel. Gravity will slam the universe into reverse, transitioning us out of this era of expansion and straight into a terrifying scenario known as the Big Crunch.
If the Big Crunch becomes our reality, the very fabric of space becomes, to borrow a phrase from one astrophysicist, sucky rather than pushy. The universe will reach a maximum size, hang there for a brief, eerie moment, and then it'll begin to contract. Slowly at first, sure, but then faster and faster. Every single galaxy, every star, every planet, and every atom will be drawn violently back together, collapsing inward at accelerating speeds until all of existence is crushed back down into an infinitely dense, incredibly hot point. And some calculations suggest this collapse could start happening in roughly 20 billion years.
The meaning behind all of this is absolutely staggering for the scientific world. Because if dark energy evolves, our basic understanding of fundamental physics, the mechanics of the Big Bang, and the long-range forecast for reality itself, it all essentially has to be rebuilt from scratch. We're suddenly realizing that the standard model we've confidently relied on for decades might just be an incomplete chapter in a much larger, much stranger cosmic rulebook.
We're being forced to realize that the cosmos isn't just a cold, static void that's passively expanding into nothingness. It's a dynamic, shifting, almost living system. The fundamental forces governing it are changing, and the universe itself may actually be bound by a very real finite lifespan. It had a birth, it's currently aging, and it may very well face a definitive, crushing, mechanical death.
And honestly, that leaves us with a deeply profound, mind-bending question about our own existence. Think about it. If our entire universe is mortal, if space and time itself will eventually fold back in on themselves, erasing every star, every planet, and every record of our history, what does that mean for our fleeting moment of consciousness? It serves as a stark reminder of our reality. Our ability to observe, measure, and even comprehend this vast, mechanical dark is incredibly rare. We exist in this brief, finite window of time before the lights potentially go out forever. And no matter how it all ends, that window of awareness is truly precious.